Okay, so when we talk about geometry, what we're really talking about is the shape of the molecule. So molecular geometries determine the properties of that molecule. It also gives us a 3D picture of the atom. The VSEPR theory is the theory used to determine the geometry. It's the valence shell electron pair repulsion theory. And all it says is that those lone pairs on the center atom will move away from each other, and it will actually force the bonded atoms closer together so that they can take up the most amount of space. So there are 5 different shapes or geometries that you need to be aware of. A linear shape occurs when you have 1 or 2 atoms attached, and then you have a 1, 2, or 3 lone pairs on the center. So for example, any of your 7 diatomics are going to be linear. So if you look at nitrogen, nitrogen has a triple bond between our 2 atoms, but because there's only 2 atoms, it's a diatomic. The other classic example that's not a diatomic is carbon dioxide. If you were to do want minus half divided by 2 with carbon dioxide, you get 4 bonds. So the carbon is double bonded to each of our oxygens, and it actually has no lone pairs on the center, but it's still linear because there's 3 atoms attached. A bent molecule will either have 2 or 3 atoms attached with 1 or 2 lone pairs. For example, water. If you were to draw the Lewis diagram for water, you have the 2 hydrogens attached to the oxygen with 2 lone pairs. Another example that we already have in our notes would be SO2. Remember, SO2 had that double bond to one of the oxygens and 1 lone pair on the sulfur. Trigonal planar occurs when you have 3 atoms attached and no lone pairs. One example would be SO3. You would have S in the middle. One of the oxygens is double bonded. Again, you have 3 atoms attached but no lone pairs on the sulfur. Trigonal pyramidal, however, has 3 atoms attached with 1 lone pair. A classic example would be NH3. So you would have nitrogen, 3 hydrogens, and then 1 lone pair on the center. So the difference between trigonal planar and trigonal pyramidal is the lone pair on the center. A tetrahedral atom or molecule has 4 atoms attached and no lone pairs. The classic example is methane. So you have carbon, and then you would have 4 hydrogens bonded. Now these are just classic examples of our different shapes. These are not the only ones that have these shapes. Intermolecular force is the force of attraction between our molecules. It's not a bond between molecules, but a force of attraction. What holds all of our water molecules together in our glass of water? There are 3 types, and the types depend on what kind of molecule it is, whether polar or nonpolar. So polar molecules are held together by London dispersion forces. This is a very weak force of attraction. So when we think about oxygen, oxygen is a nonpolar molecule, and the force of attraction that holds oxygen molecules close together is London dispersion. So between this oxygen molecule and that oxygen molecule, we have London dispersion forces of attraction. Dipole-dipole is for polar molecules, and it is a bit stronger. Hydrogen bonding is incredibly strong, so very strong. And hydrogen bonding, even though the word bonding is in there, it's a force of attraction between our molecules. It's called hydrogen bonding because you have hydrogen bonded to something else. The 3 things that you have are fluorine, oxygen, and nitrogen. So when hydrogen is next to fluorine, you have hydrogen bonding force of attraction between those molecules. Hydrogen bonded to an oxygen, again you have intermolecular force of hydrogen bonding. Hydrogen and nitrogen. Now just because we wrote hydrogen first doesn't mean that it has to be shown first. In other words, if we drew a molecule this way and had the hydrogen on the right, it's still hydrogen bonding. The classic example is water. Water has hydrogen bonded to oxygen, so the things that hold our water molecules in our glass of water together is the hydrogen bonding force of attraction. So there's an attraction that happens between these two molecules, and that's hydrogen bonding. So that's what holds our glass of water together, or our water together.